But if you haven't already guessed, that simple average predictor is extremely lazy and very inaccurate prediction system. So let's see what else we can take into account in order to make that prediction higher. So the first thing we can do is we can look at what's called bias. And we can look at bias along the users and as well as bias along the movies. And so what exactly do we mean by bias? Well, let's look at a few examples here. We might have some reviewers that are either easy or harsh. So easy meaning that they tend to give movies very high ratings, and harsh meaning that they tend to give movies very low ratings or lower than a normal user would give them. And we would compensate for that by adjusting the predictions accordingly. So, for instance, if we look at movie user D here, we see that user D gives movie 1 a rating of 2, movie 2 a rating of 2, 3 a rating of 3, which is the lowest of still all of these values, 4 a rating of 1, and 5 a rating of 2. So he hasn't even gone above a 3 here, and he tends to rate much lower than the other users. So we'd say that user D seems like he's kind of a harsh reviewer. At the same time, we can do the same thing across movies. Some movies are just very good, which means they're going to be well received by the critics, and some movies are just simply bad, which means that they're not going to be well received by the critics. And so if we take an example here, movie 3, got a 4 from user A, 5 from B, 3 from D, and then 2 more 5s. So that's much higher than the average. And, again, you can compare to that the average value that we had of 3.5 that we computed before. And, this is just on average much better than that. And so we'd say that movie 3 seems like it's a pretty good movie. So it's just going to be well received by critics. For instance, C that hasn't rated it yet. So we would adjust C's rating accordingly based upon those bias values. So now when we actually compute the bias values, technically we'd have to solve what's called an optimization problem in order to get the lowest possible error on the training set. So we could train the parameters of our predictor to, which would be the bias terms, to basically get the error to be the lowest possible. But instead we'll use here just a more intuitive way of doing that, which is really to compare the averages along the rows and columns to the raw average across the entire set, which is sort of what we were implying before. And so that raw average we said was a 3.5. And so then, for instance, if we want to compute 3's bias, we would take the mean of all of the movies that user 3 has rated. This 4, 5, 3, and 5 here. And we're going to ignore, remember, we're ignoring the elements in the test set. And so to do that, we'd take, for 3, movie 3's bias would be 4 plus 5 plus 3 plus 5. And we take the average of that, so we're going to divide that by 4. And then we want to do that relative to the overall average. So we subtract the average of 3.5 from that. And we would come out with 0.75. And so we've denoted that down here as well. Similarly, we can look at user D and compute user D's bias as the average of all the elements he's rated. So we have 2, 3, 1, and 2. We take 2 plus 3 plus 1 plus 2. Divide that by 4, because there's 4 of those. And subtract the mean 3.5 from that. And we get negative 1.50. So notice now that the bias for user 3, or the bias for movie 3, is positive. So it's 0.75, which means it's 0.75 higher than the mean, which is as we expected, because we said that movie 3 was just a very good movie. And then for user D, it's negative 1.5, which is much lower than the average, which is as we expected, because we said user D was a very harsh critic.